Let us use the definition of impulse from our previous lesson to solve problems. We are going to look at question 1. To tackle this problem, I'm going to use the I can rules. The first letter I stands for interpretation, problem interpretation. To do that, I'll read the question. A steel ball moves to the left and collides with a glass. The glass breaks due to an average force of 3,500 newtons applied over 1,600 microseconds during the collision. To best interpret this problem, it is important to firstly choose the direction, because I've noted that actually the ball moves to the left. So I'm going to choose my direction such that anything that goes to the right is positive and anything that goes up is positive. In this situation, we actually have a glass that is sitting like that, and we have a ball that comes and collide with the glass. So it means there is a ball that is coming towards the glass like that. At some point, because this ball is moving to the left, at some point it will collide with the glass. And they say here that when it collides with the glass actually breaks off. So just to draw a situation where the glass actually breaks off because the ball now collides with the glass. Now they say the glass breaks off due to an average force. So obviously this would mean that when the ball collides with the glass, it will exert a force that goes in this direction. And this force here, they say it's an average force. Remember that during the collision, we have a time varying force, and we take the average of that force. And that force, we then call it the net force. The average that we take, we call it the net force. Please go to the previous lesson to understand what I've just said. And this force, when it varies, as it collides with the hole, it will vary, giving us different forces. When it varies for us to take this average, it actually is applied over a period of 1,600 microseconds. So there is a change in time here. There will be a time that it takes for the ball to be in contact as it's exerting a force on the glass over some period of time. Now, our force, we're saying here that it is 3,500 newtons, and our time is 1,600 microseconds. Now, it is important here to remember that we measure time in the SI unit of seconds. This means we have to convert that microsecond. The micro is a metric multiplier, and actually it stands for 10 times 10 to the power negative 6. Very important to know your metric multipliers and memorize them. So how we convert this is going to be a very simple thing. We just take the 1,600 seconds and then convert the micro to 10 times 10 to the power negative 6. Please be sure that you memorize and know your metric multiplier so that you can be able to use them. Now at this stage, this thing is converted because it is in seconds. And you have to note that my force is going to the negative direction. So it's a negative force here because I chose the right as positive. And this force is going in that opposite direction. Now I'm done with the problem interpretation. I'm going to apply the next rule, which stands for classification of the problem. Classification means we link our given problem to the topics that we are studying in physics. So this is to say, when I look at this problem and this interpretation, which topic is relevant here? What topic do I think I can use to solve this problem? I mean, when I was explaining this, it should ring a bell from the previous lesson that this could be something that relates with impulse, because we are exerting a force over a period of time, and this force is an average force. Remember, an average force would be an average of the different forces that the ball exerts on the glass. The varying forces that we'll have, we'll have different varying forces that are exerted here, and all these forces, we take an average of them to get the net force, is what we discussed in the previous lesson. And this will relate to the formula of impulse being given by net force times the time. So I think I'm going to be asked around that, the knowledge of impulse. So now I'm done with classification. This step is very important because already it guides me to focus on specific topics, not to run around finding myself wanting to do other topics that are not relevant to this problem. The A is the next rule that we're going to use. It stands for answering the problem. So we actually now go to our questions to answer the problem because we have a comprehensive understanding of this problem. The first question says, define the term impulse. I expected that because during my classification, I knew, based on the information that I'm given, that this is a problem that requires the knowledge of impulse. Impulse is defined as the product of the net force and the time during which the force is applied. Now, after we are done with answering the question, we then do the last rule of N, the navigation rule. Navigation simply means that we check our answer to see that it doesn't have errors, right? And in this case, because this type of a question, we call it a concept question. It's a question that focuses on concepts, where we are required to give laws, brief explanations, or even define things, in which case here we're defining impulse. This type of a problem, when you check for errors here, you basically check grammatic errors, you check if your spelling is correct and if your sentence makes sense, to make sure that we don't lose those marks. So when I look at my statement, it actually looks good to me. I don't see any problems here. I don't see any problems on this when I reread my sentence, right? So this definition would be marked out of 2. So basically they're saying here that you should spend 2 minutes because 1 mark is equals to 1 minute. And you can spend less really on giving such a definition. Now at this stage, I'm continuing back to the A rule to answer the next question. The question says here, calculate the impulse delivered to the glass. So they're actually asking us to look for the impulse. And already we know, we discussed this in our classification and interpretation that this is a problem that requires the knowledge of impulse. And we are given the two quantities. So this problem becomes really a simple substitution problem where I'm going to put my force, which is negative 3,500. Here we're going to put our time of 1,600 times 10 to the power negative 6. Because it is a microsecond, then we're going to close the bracket. From here, this problem becomes very, very, very boring because we are going to just punch everything on the calculator. And this gives us an answer of negative 5.6 Newton second. Remember, our SI unit for impulse is Newton second. Now, this question is negative, so that means it is actually giving us an impulse that is going to the left. Because remember, we chose our right as positive, meaning anything that will go to the left will be negative. Now, let us then reapply the interpretation, the navigation rule, right? Where we want to see if our answer makes sense. Now, this type of a question that we are doing, it's a calculation problem. It's not like question 1.1 where we did a question that focuses on concepts. This is a calculation problem. Now, to look at the calculation problem, we must understand that impulse is a vector. In other words, I have to write the magnitude, which is a number, and the SI unit, and then also include direction, and I did that. But to take this a further step, I have to see if this answer makes sense. So first thing, I'll look at the direction. We're saying here that the impulse will go in this direction as well. It will give us this direction. This makes sense because remember, we said that the net force and the impulse are directly proportional, meaning they always go in the same direction, in as much as they grow or decrease with the same magnitude. And our number looks really good because we have a small time here, right? So it shouldn't necessarily be a big number. It is also possible for one to write this answer as 5.6 kilogram meters per second to the right, to the left, sorry. This will also be correct because the other SI unit, as discussed in the previous lesson, of impulse is a kilogram meters per second. Newton second is the same as kilogram meters per second. Now this question will be marked out of 3 marks. So they mark the correct formula, the correct substitution, and they also mark your final answer, including direction as well, and that gives you a 3 marks.